Hello and welcome. In this video tutorial, we will be looking at the homework solutions for Unit 8, Lesson 3, Sectors of Circles. Please remember to pause or rewind the video as necessary. Let's begin. Question number 1 involves a measurement and a construction. Now, I don't know that all of you have a ruler, a compass, and a protractor, so I'm just going to go ahead and draw what this sector should look like. I'm going to sketch it out. And then we're going to just simply move on to question number 2, which uses the information in question number 1. So just go ahead and draw a horizontal line across your page right here. And the horizontal line is supposed to have a radius of 7 centimeters. So we'll go ahead and label it 7 centimeters like that. And then we'll go ahead and draw another line angled up about this much. And then we'll go ahead and complete the curve like this. That would be a section of a circle or a sector. A sector is just a section of a circle or part of a circle. A piece of the pie, right? Well, the angle is supposed to be 40 degrees. Okay, so this has a radius of 7 centimeters as well. Now in question 2, we're going to use this information to determine the area of the sector. Now, the area of a sector, if you looked at a full circle, remember the area of a sector is just a part of that circle. It's a percentage of the whole circle. And percentage means part over the whole. So what we'll do is we'll take the area of the full circle, which is pi r squared, okay, and we're going to multiply that times the percentage of what we're actually finding, which would be, we take the area of the angle, we take the angle of the sector divided by the angle of the whole circle, and that would give you the angle of just the sector, or the area of just the sector. So to get the area of this sector, we're going to take the 40-degree angle over the full 360. So this would give you the percentage of the area. So it's still the area of the circle, but it's only a percentage of the area. Okay, so we're going to go 40 over 360 times pi times 7 squared. Now you can see nowhere in here do you have pi in your answer, so you should be prepared to plug that in your calculator. Now the easiest way to plug this in your calculator would be go 7 squared is 49 times 40 times pi. Multiply all that together. Then hit enter, then divide by 360. If you do that, you'll approximately get about 17.1 square centimeters. Which is basically option 4. Now in question 3, it says, which of the following sector has a radius of 10 inches and a central angle of 30? Which of the following is its arc length in centimeters? Well, arc length is only a percentage of the full circumference. So the idea behind this unit, sectors represent percentages of the area, part over the whole times the area. Arc lengths, not arcs. Arcs are measured by the central angle, but arc length is specifically the distance around the edge of that part of the circle. That right there is a percentage of the circumference. Now the circumference is 2 times pi times the radius. So what we're going to do is we're going to take 30-degree angle, and we will go, I'm going to call arc length AL. So arc length is AL. And we're going to go 30 degrees over 360. That's our percentage of the circumference. So times 2 pi r. So we're still going to take the circumference, but you're only taking a percentage of the circumference. Okay, let's multiply this. We're going to go 30 degrees over 360 times 2 times pi times a 10-inch radius. Now you'll notice all your answers are in pi this time. So what we're going to do is we're going to multiply 2 times 10, we get 20. 20 times 30, we get 600 pi over 360. Well, you can see a factor of 10 will cancel, and this reduces to 60 pi over 36. Well, if we keep reducing it, both the top and bottom are divisible by 12, and we get 5 pi over 3 as the area of our sector. And that would be option 1. Number 4, the area of a circle is 18 pi square inches. If the area of a sector is 6 pi square inches, then which of the following must be the central angle? Okay, well, the central angle, remember, the central angle represents the part over the whole. So I'm going to let the central angle equal x. Okay, and so we would go x over 360, that's your percentage, of the area. The circle's area was 18 pi. Okay, in fact, actually, let me just write this down. Of the area equals the sector area. Okay, so I'm just going to replace this with the numbers in the problem. So x over 360, that's the percentage of the area, which is 18 pi, equals the sector area, which was 6 pi. Now you can see one of the factors of pi will just cancel, which is nice. And 18, let's see here. This reduces, if I actually multiply this through, I get 18x over 360 equals 6. Well, this actually reduces, nice. 18 goes into 18 one time, 18 goes into 360 20 times. And so this becomes x over 20 equals 6 over 1. Go ahead and take your cross products, and we get 1x equals 120 degrees. And that would be option number 3. In number 5, it says Luca is designing propeller system that consists of 3 blades, each of which is identical. The blades are sectors of a circle that have a radii of 4 inches and a central angle of 20. The blades are to be made of steel that weighs 16 grams per square inch, determine the weight of the 3 grams. So take this in pieces. Like, there's a lot going on here, okay? A lot going on. To determine the weight of the gram, here's what we should know. If we know that there are 16 grams per square inch. So if I go 16 grams per square inch, and I multiply it times the area, if I multiply it times the total area, which is in square inches, you'll see square inches cancels with square inches, giving you the weight in grams. So ultimately, weight is going to be found by taking 16 times the area. Okay, that's ultimately how we're going to do it. Okay, so let's find that total area. The area would be the area of 3 blades. So we'll find the area of each blade and multiply it times 3. So the area of each blade would be a percentage of the circle. So 20 over 360, that's a percentage of the circle, percentage of pi r squared. Well, that would be 20 degrees over 360 times pi, and the radius was 4 inches squared. That's about 2.7925 square inches. So that means the total area would be 3 times that because there's 3 blades for a total area of about 8.38 square inches. So to get the weight, we're going to take the fact that there are 16 grams per square inch times the area itself of 8.38 square inches. You'll notice the areas cancel and you simply just multiply the 2. And 16 times the 18.38 gives you about 134 grams. That's how much the propeller system will weigh. Number 6, an ant crawls around the perimeter of a circle whose radius is 2 feet through a central angle of 72 degrees. What is the distance? So if we're looking distance here, now we're talking arc length. We're not talking sector. What's the distance to the nearest inch? Now notice it's giving you feet. So what we'll do is we will find the arc length in feet and then convert to inches. That'll be our plan. Okay? Or you can convert 2 feet to inches and work that way too. Either way, you'll still get the same result. In fact, that might actually be a little bit easier. There are 12 inches in 1 foot. Therefore, 2 feet would be 24 inches. So that is going to be your radius right there, okay, 24 inches. So the arc length is a percentage. Remember, it's a percentage of your circumference. So the central angle is 72 degrees, so 72 over 360. That's your percentage right there of your circumference. Circumference is 2 times pi times the radius. So we're going to go 72 over 360 times 2 times pi times 24 inches. Again, all of this is over 1. So your best bet is just multiply 72 times 2 times 24 times pi, hit enter, and then divide it by 360. And if you do, you should get roughly about 30 inches. Question 7. Isosceles triangle ABC is shown with legs that measure 8 inches and a vertex angle that measures 50 degrees. Determine the area of ABC. Okay, so here's what we're going to need to do in order to figure out this area. So what we'll do, we need to figure out, if you looked at this triangle here, this triangle, I'm gonna go ahead and trace it so you can see it better. Here's 1/2 of the triangle. What we're gonna do is we're gonna find half of the triangle first and find that side, and of course double it, and we'll have the whole base. Okay, so we'll get that part first. But essentially what we're gonna do is we're gonna take that triangle right there, okay, and we're gonna use that as a basis of how we're going to find what we're going to find. So in other words, that angle at the top is not 50 degrees. If you looked carefully, we just cut this big triangle into 2 little ones. So that would actually be 25 degrees. And that would be 25 degrees. So the angle there is 25 degrees at the top. This is 8. The hypotenuse is 8. And I'm looking for that base right there. I'm looking for X. So now this represents our, and if I kind of rotate this triangle a little bit so you can see it, I'm given an angle, I'm given the hypotenuse, and I'm given the opposite side. So I want to use a sine ratio here. I'm going to use trigonometry. Remember, with trigonometry, you have to know what sides you're working with here. So your SOHCAHTOA acronym helps you remember that sine involves the opposite side divided by the hypotenuse. Cosine involves the adjacent side divided by the hypotenuse. And tangent involves the opposite side divided by the adjacent side. So I have the opposite side and the hypotenuse. So I'm going to be using, and the opposite to a 25-degree angle, that is, I'm going to be using sine to find that leg right there. So we're going to go sine of 25 degrees equals opposite over 8. Go ahead and multiply both sides by 8, and you'll get that side right there. So x is equal to 8 sine 25. So the entire base of the triangle would be 2 times that. So the base would just be 2 times 8 sine 25. Okay, and so in other words, 16 sine 25 is roughly about 6.76 inches. Okay, on that side. Now, how do we find the height? Let's take the same triangle, take that exact same triangle, and the height of it right here is actually the adjacent side. So what we're going to do is we're going to come back to, and we're going to find the height right here, but this time we're going to use a different trig function. So to do that one, we're going to use adjacent side over hypotenuse. We're going to use cosine. So the cosine of 25 degrees equals height over 8. Multiply both sides by 8, and you'll get the height is equal to 8 cosine 25. And go ahead and multiply that through. 8 cosine 25 is about 7¼ inch, about 7.25 inches. Okay, so now, very simple, to find the area, okay, we'll find the area of this triangle, it's base times height divided by 2. So your base would be 6.67 inches times the height, 7.25 inches over 2. And we should get about 24.5 square inches for the area of the triangle. So this is the area of the triangle AT. Part B, determine the area of the circular sector. Well, the circular sector has a radius of 8. So we're going to go, the area is equal to a percentage. So we take the central angle, which is 50, over 360, which is the total circle, times the area of the circle, pi r squared, which would be 50 over 360 times pi times 8 squared. Throw that in our calculator, and we get about 27.9 square inches. Okay, the area of the shaded region is just simply going to be the area of the sector minus the area of the triangle. So 27.9 minus 24.5 gives you about 3.4 square inches.